Hello and greetings everyone. My name is Cempaka Amalin Binti Mahadzir and my supervisor technologist Dr. Ahmad Fateh bin Mohamad. My research title is Enhancing Photovoltaic Power Prediction Accuracy Using Real Data Trained Artificial Neural Network (ANN). For the introduction of this research, energy may be supplied and traditionally dependency on fossil fuels and 5 greenhouse effects. This is why we should use photovoltaic or solar energy. The problem statement of this research is that the PV panel is dependent on weather, peak sun hours, and temperature. PV only generate power according to its rating under the STC. Many equations and complicated calculations are used in predicting the PV power output. So, the solution to these problems as the objectives of the research is by designing an user interactive platform and developing of ANN configuration to predict the solar power generation. For the novelty and uniqueness, the first one, integrating renewable energy sources. This innovation allows for the efficient captures, storage, and distribution of renewable energy, reducing reliance on traditional fossil fuels and decreasing the carbon footprint. For the second uniqueness of predicting solar panel power output using ANN from its accuracy and sophistication, it continually refines its prediction, enhancing its accuracy over time. Lastly, generating the best configuration for ANN in predicting solar output. The generated configuration maximizes predictive accuracy while potentially reducing the need for exhaustive parameter tuning. ANN can bring forth a multitude of benefits to both intended users and society. For the first one, reducing greenhouse gas emission, businesses and utility companies can fine-tune their operation to produce and distribute only the required amount of energy. The second one, balancing energy generation. This enables energy providers to proactively adjust their energy mix to ensure a consistent and reliable energy supply. Lastly, reducing time-consuming processes. This leads to streamlined operation, reduced downtime, and quicker responses to fluctuation in demand or supply. Next, for the commercialization potential. In the solar industry, for efficient energy management and grid stability, solar power companies can achieve highly precise prediction of power generating. Moreover, climate researchers can utilize this to evaluate the long-term impacts of renewable energy sources. Researchers can simulate various scenarios and assess the feasibility of widespread solar adoption in different regions. Now, let's go through the developed GUI and ANN configuration. This application located at the app section. Click here. So, this is the main menu for the prediction of PV power output. Click the Start button. And the first step is the prediction of PV power output for 1 day. Here, user can key in the desired input values. This can also calculate the cell temperature by entering the ambient temperature plus 28.75 if the cell temperature does not require. The reset values function is also to reset all the values to 0. After keying all the inputs, click the Generate Output. And there you go, output result for PV power output. Let's head to the ANN tabs. By clicking the Start ANN button, it will automatically generate the number of hidden neurons, training progress, and plots like training performance, training state, error histogram, and regression. This research has won Gold Award in VIC 2022, Silver Award for RISE 2022, and Silver Award in NICE 2022. This research also has been presented in IEEE Malaysia and has been published as conference in IMCCRT 2022. And that's all from me. Thank you.